In February 2019, a 200-year-old arsenal of missiles was found in the state of Karnataka in southern India. Nothing special for local archaeologists. After all, it was on this territory in the 18th century that the Kingdom of Mysore was located, whose ruler, Tipu Sultan, won many victories with the help of missile forces and shamed the omnipotent East India Company. Citizens of Mysore modernized the design of the long-known Chinese fire arrow, placing the powder mixture into a metal case. This meant their missiles could fly up to a kilometer or more. It was for this purpose that the Mysores used incendiary charges or attached long blades to the head part. As the rockets went down, they lost stability and the furiously rotating blades slashed both the infantry and the riders. However, after a series of defeats, the British recouped and adopted technology, so William Congreve at the beginning of the 19th century presented his missile, which was already used in the Napoleonic Wars. Although these inventions appeared and developed as weapons, scientific progress in the 20th century opened up a new field of application for them: space exploration. We're engaged in experimental rocket science. That is, we are building rockets on which you can conduct scientific research or participate in student competitions that are held in Europe or America. Well, as students say, for pleasure and for upgrading of engineering skills. Serhiy Pipko is head of the students group at the Ukrainian National Aviation University. In fact, this is a design bureau which with every year seeks to produce more and more powerful and technically complex missiles on its own. The students do everything, starting from fuel, engines, electronics, etc. Most recently, the altitude record for a student rocket was 40 kilometers. But in spring of this year, students of one American university launched a rocket that reached 100 kilometers. This is a suborbital rocket. How is rocket motion developing in Ukraine, a country where some of the best booster rockets in the world for space flights are produced? Why is the student rocket engine made of cardboard and fuel is called caramel? Did Serhiy Pipko and his wards manage to conduct successful launches? UATV begins the countdown to some exciting rocket tests. American engineer Robert Goddard is considered to be the father of modern rocket science. He knew about the achievements of the Chinese, Indians and British, but they all used a particular mixture as fuel based on gunpowder. After years of experiments, Goddard discovered that a mixture of liquid oxygen and gasoline gives more traction. He launched the first liquid fuel rocket in March 1926, which took off just 12 meters into the air and fell on a field full of pumpkins. But there was no doubt. It was on this principle that engines capable of reaching space should work. As a result, the United States and Soviet Union became the main rivals in the space race. The amateur experimental rocket science began in only one of these countries. In the United States, it was supported by the state from the 1940s, which was when rocket science started. As a matter of fact, there was nothing of the kind in the Soviet Union. Rocket modeling was well developed. There were groups, there was sports rocket modeling, which performed well in the Union, and now sports rocket modeling is pretty well developed in Ukraine. Our athletes get quite good places in international competitions, including top places. The link between these two hobbies is very blurred, but rocket modeling is what school children are capable of doing. Experimental rocket science is for people with special engineering knowledge, that is, at least students. Serhiy Pipko didn't know anything about the separation in his childhood. Somewhere in the 5th form, someone showed me how to make a rocket engine out of celluloid and that it will fly. I got really excited about it. Then there was studying chemistry, how to make gunpowder, how to make an engine. The school model of the rocket will fly as it turns out, and the experimental one should have clear parameters calculated in advance. The necessary speed, the trajectory along which it will fly. But when in 1998 I got the internet, I realized that what I still did was something I did not need, that was quite weak. It was from US sites that I learned how to design engines, design rockets, calculate everything and do it. Not just to collect something, to make the calculations in order to make it fly in line with your sums.
Так, чтобы сделал, и оно полетело так, как ты рассчитал.
Advanced space industry plants remained in independent Ukraine, like the Pivdenmash plant in Dnipro. Unfortunately, there was no experimental rocket science that would help to bring motivated young specialists to this industry. But Serhiy Pipko and other enthusiasts vowed to change the situation. At first, I was one of the organizers of the CIS Missile Forum. I organized the Ukrainian Missile Forum, and now we have our own company there. At the forum, I managed to find colleagues in this sphere, and I organized a missile group in Kyiv. There's also a student group that builds rockets in the city of Dnipro, but our student group carried out the first successful launch of a student rocket in Ukraine. A modern experimental rocket is an amazing combination of highly intellectual work with down-to-earth technologies. Especially for UATV, Serhiy Pipko tells us how he organized his work with students, what parts these devices are assembled from, and how all of this is done. The foundation of any rocket is the engine. Liquid fuel, even though it has shown its effectiveness in rocket science, is not suitable for the work of amateurs and students. It is expensive, toxic, and too explosive. Let the legacy of Robert Goddard fly into space, but caramel fuel engines using Bill Colburn's technology are more modest. It was just a mixture of sugar and saltpeter, which was pressed, but it was very inconvenient. And then Bill Colburn, an American, came up with the idea that sugar can be melted. Caramel is a melted sugar, so you can melt the sugar, mix it with nitrate, and you get fuel that's not pressed but monolithic. Much larger size engines can be made of such monolithic fuel. The standard chemical composition of caramel fuels by weight is 65% potassium nitrate and 35% sugar. Sugar was later replaced by sorbitol, an alcohol derived from glucose. Such fuel can even be prepared at home. Serhiy says it is about 1.5 times less efficient than liquid fuel for modern stages and accelerators, but for small missiles this is more than enough. Besides, the engine body is not made of metal, but of ordinary cardboard. Now I have cardboard engines that provide traction of 50 kilograms. If you can make a cardboard engine for 100 kilograms of traction out of cardboard because it's safe. We have metal engines, we test them. If for whatever reason the pressure in the engine is exceeded, the engine may explode. In such case, the resulting fragments can be cardboard or metal, and this is a big difference. The engine is designed in such a way that the area where the combustion occurs doesn't come into contact with the cardboard and doesn't destroy it. Such missiles don't have a nozzle and a stream of fire and smoke breaks out of the hole in the fuel. It is good because all its parameters have been calculated long ago. The second part of the rocket is electronics. The electronic filling of a rocket usually consists of some kind of flight controller that has sensors. This is usually a barometer. It measures air pressure, calculates the flight altitude, an accelerometer that shows acceleration, and a gyroscope that shows the rotation of the rocket in all three axes. These sensors primarily determine the start of the engine, the end of the engine, the apogee, which is the highest point of flight of a rocket. While space rocket accelerators have learned to return to Earth intact only recently, these devices were initially designed for a soft landing. When the accelerometer and barometer show that a rocket has reached the highest point of its trajectory and begins to decline, the microprocessor decides to throw out a small parachute and a large one at a height of 200-300 meters. The dimensions and configuration of the cup also need to be calculated based on the mass of the apparatus. It's great to install a navigation tracker since sight of it is lost at a height of several hundred meters, and the wind can carry it for kilometers from the starting point. Plastic frames are now printed on 3D printers. We use the simplest plastic pipes for the time being, for sewerage, for ventilation, for electrical wiring. Pipes are very different, just depending on what size, what rigidity of the pipe you require, weight, material, is it glued or isn't. They are light enough and durable enough for our tasks today. Stabilizers are cut out of plywood on a laser machine. The nose cone can be made from the cut walls of the pipe or also printed on a 3D printer. All these are only the most basic tasks in building a rocket, which are divided into many small ones. How do you captivate modern students with such a long and laborious process in their free time from study. Serhiy Pipko remembers that he managed to form a university group thanks to the sensational work of American businessman Elon Musk, who in February 2018 launched into space his red roadster with a mannequin behind the wheel. It was fashionable, it was cool. Build a rocket? Of course, I will build a rocket. The initiative didn't come from the authorities, but from a student organization called the Council of Young Scientists. Each rocket is designed in 3D editor, then one team makes the engine, the other assembles the electronics, and the third the body and the remaining parts. Everything which we have is still at the initial level. We're building rockets that go up a kilometer. Now we're building them to go 3 kilometers, 5 kilometers. That is, these are simple missiles, but neither is this rocket modeling. At the end of August, Serhiy Pipko and the student group planned to launch 2 rockets at once. The first, Mars, can, according to calculations, rise to an altitude of 1 kilometer to throw miniature satellites. Of course, they can't enter orbit in any way. It was just that the students designed the hull with compartments and cutouts for the payload. The engine is fixed in the rocket and then it is placed on the launch pad. The countdown begins. Something's wrong. Ignition occurs remotely, through a wire using an electric spark. Apparently, there was a problem with the contactor battery. And here's the second attempt. Will Mars get off the ground? The rocket blows away, it begins to decline, and everyone is waiting for the parachute to open. But that doesn't happen. Our drone operator coordinates specialists from the air. What remains of Mars is brought to the launch site. Fortunately, all the electronics survived. Already back in the workshop, Serhiy can analyze what happened. The data from the controller have been read in full. The altitude reached was 450 meters. After the apogee passed, the controller sent a signal to trigger his knockout charge in time, and head part was fired along with the parachute. But for some reason, the rocket descended without a parachute. The rocket flew nose down and stuck into the ground at high speed, broke in half at the weakest place, where there were cutouts in the hull. The second rocket is called 42. It refers to the books of British science fiction writer Douglas Adams. It is designed to fly 3 kilometers, but today students are testing a rescue system at a lower altitude. 5, 4, 3, 2, 1. Lift off. You can pay attention to the fact that the engine works up to half the vertical path only. Then the rocket flies through inertia. The first parachute leaves without problems, but the second fails once again. As a result, the device falls to Earth at a speed of 25 meters a second. It turned out that the second parachute ejection signal was not received due to a failure in the electronics. The flight altitude was 750 meters. The landing was tough enough, but the whole rocket remained intact. The only thing that happened was that the fairing split in this place, which means the rocket is safe. We just re-reprint the head fairing and we'll launch it once again to a low altitude so as to work out the entire rescue system in full. Serhiy says that their capabilities are now limited not by technologies that would enable a rocket launch of 10 kilometers or more, but by size of the landfill. If something goes wrong, the device should not fall on residential areas. And when a suitable site appears, will Ukrainian students compete with their Western counterparts in suborbital flights? There are no big plans for the next 10 years. People are very different. Someone is engaged in such a strong passion, someone is simple. Today he is interested and he is involved. People are very different. We take everyone who can do something. Is there a future Elon Musk among them? I can't tell you right now. We just do what we like and that's all. Let the Ukrainian rocket builder laugh it off. But this is only because he's focused on current tasks. After all, what team of amateur engineers doesn't want to make the first homemade rocket in history that will enter orbit around the Earth?